right, this is P.6 day 2. Here is the assignment. Now, rational expressions is what we started talking about yesterday. Rational means fraction. And yesterday we just did some simplifying, we did some multiplying and dividing. Today, adding and subtracting. It's a little trickier. Just like with regular fractions, adding and subtracting is actually harder than multiplying and dividing. So, how do we add and subtract fractions? Well, the denominator has to match. Once the denominators match, then we can fulfill the operational request on the top. So in this case, they're asking us to make one full fraction. If the common denominators are common, we simply write them as one combination. And then at the top, we're going to take x and we're going to subtract 3x and 2. Remember that when you subtract more than one thing, you have to subtract each of them individually. So we're going to say x is taking away 3x. It is also subtracting 2. You need to distribute your subtraction all the way through your polynomial. Number one mistake that pre-calc students make is they do not subtract all the parts. All right, now that we've done this, I can combine like terms. I've got a 1x essentially right here. Take away 3x, that would be negative 2x. And looking at the numerator, I can actually factor the negative 2 out now, leaving me with x plus 1. Ooh, now that's interesting because that matches the denominator, which means that those two factors will cancel, and our simplified answer is just negative 2. Example 2. Do these two denominators match? No. Okay, well, that means we're going to have a little bit more work to do. How do we get them to match? Well, basically, we make a pair. So the first one is essentially missing the x minus 1 component. So we're going to take the x minus 1 and multiply it on the top and the bottom of this fraction. When you multiply a fraction by the same thing on the top and the bottom, you're basically just multiplying by the number 1, because this is the number 1. Something divided by itself is just 1, isn't it? Okay. So that allows us to give me both of the factors in the bottom part of this fraction. So I have 3 times x minus 1 on the top, but then I have both x plus 1 and x minus 1 on the bottom. Okay, how do I have both x plus 1 and x minus 1 on the second fraction? Well, you can see I only have the x minus 1. So if I want to also include the x plus 1, I'll multiply it on the top and the bottom. And you can see on the bottom now I have both of those parts. I have the x plus 1 part and the x minus 1 part. That is how you get a common denominator. So now you can see this denominator matches that one. All right, now I can combine the fractions. Well, I'm going to add this part here, which is 3x minus 3, to this part here, which is 5x plus 5. Okay. So that would be this. Now I don't have to worry about adding both of these, because when you add things, it retains the original sign value, meaning positive or negative. You don't have to worry about it, as with subtracting. Okay, so what do I have here? 3x plus 5x is 8x. 5 minus 3 is 2. And the denominator is still x plus 1 times x minus 1. Now, you can write your answer in two ways. You can either write it in factored form, which as the top you can see we can factor out a 2, which would look like this. Or you can write it in expanded form, which is more like this. Okay. Either way, whoops, can you see that? Yep. Is a perfectly good answer. I'm thinking that the tests and the reviews and everything will be more in factored form. So this would probably be better to leave things like that. But just recognize that these two are the same and they are equally good. All right. Now, this kind of thing can be tricky. Finding the least common denominator. Well, when we do that, we're essentially helping us to add or subtract things that are more complicated than example number 2. So, okay, let's take a look at these two examples. So I'm going to factor them and see what kind of denominator factors I have. Here, I can factor x squared minus 6x plus 9 into x minus 3 times x minus 3. This is a separate entity. I'm just going to write it over here then. Can be factored because this is a perfect square binomial, x squared and 9, and then the minus in between, into x plus 3 and x minus 3. Okay, so for this example, you should see two unique factors. If you basically make a list of all the different types of factors, we really only have two types. We have the x minus 3 type, if you look at all of them, and we have the x plus 3 type. That's it. Those are the only two kinds of factors I have. So I'm going to list them here. I have an x plus 3 and I have an x minus 3. What is the maximum number of x plus 3 that I would have in any one denominator? Well, I have 2 here. I'm sorry. I only have 1. So that's just 1. Now the x minus 3. What's the maximum number of these I have in any one denominator? Well, I have 1 here, but I have 2 here. So 2 would be the maximum number that I would have in any one denominator. So I'm going to say 2. Therefore, the least common denominator of this and this would be 1 of these and 2 of these. So I'm going to write that down. I have 1x plus 3 and 2x minus 3s. So you can write your answer like this, or sometimes when we have two binomials that are exactly the same, x minus 3 times x minus 3, we can write that as x minus 3 quantity squared. That's also perfectly acceptable. All right, now the last example, number 4. We're going to have to go through the same process, but then we're going to use the least common denominator in order to find the difference between these two things. Now that's going to take a while, so I'm going to go to a second video for that.